Okay, so I was saying today we are focusing on partial fractions. These are questions from tutorial sheet 2. Okay, so as usual, if you have any questions, you are free to ask me. Just unmute yourself and then you can ask me your question. Okay, don't feel shy, no one will see you. Okay, the main business is that every one of us should know how to solve these partial fractions. Okay, so before we even solve any question, there are about 5 rules that we have to know concerning what? Partial fraction. If we just know these rules, then it will be easier for us to solve any type of question that can come under the what? The partial fractions. Okay, so let's go over the 5 rules and then we'll come back now and start solving what? These questions. Okay, so when you're given a partial fraction to decompose, okay, you are given a numerator, or in short, you're just given a fraction, right? So that fraction has a numerator and it also has a what? A denominator. So the first thing that you have to do, rule number 1, okay? Rule number 1. The first thing that you have to do is that you have to look at the numerator that you've been given, okay? So you check your numerator, okay? And then you go for the term that has the highest power in that numerator, okay? And then you compare that highest power in the numerator to the highest power in the denominator, okay? So if the numerator has a power that is equal or greater than that of the denominator, then before we do any partial resolving, we have to divide that expression using what? Long division, okay? And then if the numerator has a degree that is lesser than the one in the denominator, we just go straight forward into decomposing it, okay? So for those who are not understanding what I'm saying is this. So the first rule I'm saying, for example, we have this expression where I have 2x squared, okay, plus 9. And then I'm dividing this, let's say by x squared plus 2, okay? Let this be my first example. And then my other example, let me put x to the power 3 plus 4x, okay? And then I'm dividing this by, let's say, x squared minus 4. Okay, so when you look at these two expressions, okay, when I look at the x here and its highest degree, it is 2, okay? Let me put this as 9x plus maybe 5. It should be like that, okay? So the highest degree in the numerator, I can see it's 2. Even the highest degree in the denominator, I can also see it's what? It's 2. So for such type of questions, you first of all do a long division, okay, using these rules, okay? So you put this as your divisor here, and then you put this as what is dividing this, okay? If the highest degree here and the highest degree are equal, or if the highest degree in the numerator is greater than the one in the what? In the denominator. Okay, so always check your numerators and your denominators before you do anything. Okay, and then once you pass this step, let's say maybe you found that the numerator is lesser. Okay, let's say we have this expression where we have x on top, and then in the bottom we have x squared. So we know here that this one has 1 as the power, that one has 2. Okay, so the numerator power is less than the power of the denominator. So here we just go straight into the decomposing, okay? But I'll show you the step. Okay, so once you've gone through this first step, then you will be faced with, I think, 4 types of equation, if not 3, okay? So the first one is what we call as the linear type. Okay, so this linear type is something that looks like this, okay? Maybe you have a function on top here, of course, with a lesser degree than the one in the denominator. And then you have linear factors, let's say x minus 1, minus a, and x plus b, okay? So we see that these are linear factors here, okay? There's no x squared there, so it's linear, okay? So if you have something like this, okay, it is what we call as a linear type of partial fraction. So how do you decompose this? You just say this is equals to, and then you put line plus another line. Okay, so on top of these lines, you're just going to put any choice of capital letters that you want. So in this case, I can put A and B, and then under them, you put each one of these what? Factors. So you can say this is X minus A, okay? And then that is X plus B. Okay, and then you do the decomposition as usual, okay? Sometimes this denominator may come in an unfactorizable manner, okay? So meaning you have to factorize it. Sometimes it can be like this. Maybe I have a function on top, and then down there I have maybe x squared, okay? And then I say minus 5, minus 6. So here you first have to factorize this guy in the denominator, okay? And then you get those linear factors, and then you do the same thing like we did here. Okay, so this is the first type, the linear what? Type. And then after the linear type, you have what we call as the repeating factor type. Okay, so the repeating factor type, let me put it here. So this is 3. So we are talking about the repeating. Okay, repeating type. So on the repeating type, you can have a function f of x on top. Of course, you should have a lesser degree than the one in the denominator there, okay? And then maybe you are given x minus c, and then they say squared, okay? So this squared, it means this x minus 3 is coming how many times? 2. So it's what? It's repeating, okay? So how do you handle such a factor in the denominator? Okay, you say that this is equals to, you put a, okay? And then you get this factor, the factor that is just inside, like x minus c, and then you say plus b, okay? And then you write this same factor, but to the power 2. So it's like you are increasing the powers. So this is power 1, and then x minus c, power 2, just like that. And then you proceed with the decomposition. So this means that if I had f of x, okay, and then down there I had maybe x plus a, okay, and then to the power 3. It means this will be decomposed into what? A over, okay, x plus a to the power 1, okay, plus b, and then I have x plus a to the power 2, and then plus c, okay, and then I have x plus a to the power what? 3. Okay, what has happened there? This is power 3. So you see that if you have a repeating, you have to put the factors in increasing order of powers, okay? The same factor, but you're just increasing the what? The powers. So if it's 3, means you have 3 factors there. One will be raised to power 1, power 2, and then power 3. So this is the second type, where you have a repeating factor, okay? So you see when we start solving the questions, we start using these things, but I thought it was important for you guys to know them. Okay, and then from there, we have a third type, okay? So this third type is what we call as unfactorizable quadratic factor, okay? Unfactorizable, you can't factorize it. Unfactorizable, I don't know the way it continues there, but unfactorizable quadratic factor. So this is a factor such as this. So for example, I have f of x on top, and then down there I have x squared plus a, okay? So this x squared plus a, it can never be factorized, no matter what you do, okay? No matter what you do, you can't factorize this guy here. It's unfactorizable, okay? So how do you decompose this? You're going to write dash plus, okay? You're going to write dash x here, and then plus dash. Okay, I forgot to put one factor here. So you may have 2 factors, another maybe x squared plus b like this. Okay. Okay, if it's fine, let me just do for 1. Okay, so if you just have 1 there down, then it means when you're decomposing, you're going to write dash x plus dash, okay? And then all this should be over this same unfactorizable factor. So this is what you're going to do here. So what does that mean now? Okay, what does that mean? It means here you are going to put any letter of your choice and then there any letter of your choice. So in short, when you're decomposing an unfactorizable factor, you have to put ax plus what? B, and then divided by that unfactorizable factor. So these are the rules that you have to follow, okay? If this factor is unfactorizable, okay? Quadratic and factorizable. So those are the three types that you can experience, and then they can try to twist your mind. They can combine all the three types. So the linear, remember the linear, the repeating, and the unfactorizable one. They can combine them into one question. Okay, so let's see. It can be like this. So we have f of x, and then the factors here of one, a linear factor, a plus x plus a, and then our repeating one like this. This should be b. Okay, and then at the end there, I'm going to have an unfactorizable one. Let me say x squared like this. Hey, the squared should be on x plus a. Okay, sorry for that. So you have x squared plus a. So this is what you have. So you can see that in this question, we have all the three types of denominators that we can have. We have a linear, we have a repeating, and we have the what? Unfactorizable one. So how are we going to decompose it? Okay, we follow the same rules for each factor there. So for this one, which is linear, we're just going to say a over what? The same factor. And then for this one, which is repeating, we are going to say plus b over x minus b, okay, to the power 1 plus c over x minus b to the power what? 2, and then plus this unfactorizable one. We said, how are we going to write it? Okay, so this is a, b, c. So the next one here should be dx plus e, okay, divided by this factor, which is what? Unfactorizable. Okay, so guys, those are the rules when you're dealing with what? Partial fractions. So now, having explained the roots, I hope no one will get lost when we start solving those questions, okay? So I'll be showing you that you see this rule that we talked about, this is how you apply it here, okay? So if you have any questions, you're free to ask. Just unmute yourself and then you can ask me, okay? If there are no questions, I'll proceed to start solving those questions that we have on partial fractions. Okay, so let's look at these questions. So the first one there, you can see that in the denominator, okay, when I multiply all this, the highest power of x I'll get is what? X squared. So it means on top there I have x, and then down I have x squared. So this one here we can decompose it. That's what the rule said, okay? So it's codifying to be decomposed. And then what is remaining now? Identify the type of denominators or the type of factors that you have. We see that in this case, the type of factors that we have are just linear factors. Okay, I can see x minus 2, and then I can also see x plus 3. So those are linear factors. Okay. Okay, so what are we going to do with those linear factors? Okay, so we know how to handle this one. So let's get this one and solve it here on the board. Okay, so the first one here, we have 6x minus 2 divided by x minus 2, okay? And then we have x plus what? 3. Okay, so since these have linear factors, we're just going to say this is equals to a over x minus 2, and then plus b over what? X plus 3. This is what we are going to have. Okay, so from here now, what is the next step? Okay, what is the next step? Okay, so here we have two ways in which we can go about this, okay? But I'll teach you, I think the one I'll teach you, I think that's the simplest, okay? So when you reach here, when you decompose this into this, okay, what we have here, your next move is to multiply everything by the denominator that you have here, okay? So we are going to multiply everything here by this denominator. So we are going to say x minus 2, okay, x plus 3, and then multiplied by 6x minus 2. Can even put it in brackets, divided by x minus 2, and then we have x plus 3, okay? And we are saying this is equals to, so this factor here is multiplying everything. So we can put these in brackets like that. So we have a over x minus 2, and then plus, we have b there over x plus what? 3. So this is what we have, and all these are in these big brackets here. So what is going to happen here when you multiply, okay? What you see is that when I multiply this factor here, multiplied by this, and then I divide this, it's like I'm just canceling out this factor and this factor, okay? So what am I going to remain with there? I'm going to remain with 6x minus 2. And then this is equals to, then when I multiply this factor, x minus 2, x plus 3, with a over x minus 2, it means this x minus 2 and this x minus 2 are going to what? To cancel. So what are we going to remain with? We are going to remain with a multiplied by x plus 3. So we are going to write a x plus what? 3. Okay, and then from there we multiply again. So we multiply this factor that is outside here, okay? We multiply it by that factor that we have put outside the bracket. So this factor, whole factor, this one, multiplied by b over x plus 3. So it means the x plus 3 and this x plus 3 is going to do what? To cancel. So what are we remaining with? We are remaining with x minus 2 plus what? B. So that's what we are going to write here. B and then x minus what? 2. Okay, and then from here, just expand the right-hand side. So we have 6x minus 2 is equals to a multiplied by x, we're going to get ax, plus a multiplied by 3, it's 3a, plus b multiplied by x, bx, and then b multiplied by minus 2, we're going to get minus 2b. Okay, so we are seeing what is happening, right? So this will be x, 6x minus 2 is equals to, we're going to get everything that has x, and then we put them together. So it will be ax plus bx. And then we see that the x is common, so we can factorize it, right? Okay, so here we're just going to write a, okay, plus b, to write this a number. Hey, what is happening to my pen? Okay, so we have a plus b, and then we can factorize the x. Since both of them, this one and this one have an x, so we can write the x outside, right? Okay, and then plus, we are remaining with 3a minus what? 3b. I mean 2b. Okay, and then from here, what do we see? We see that on the left-hand side, we have a term that has a constant and an x, okay, and a term that is just constant. It's the same situation that we can see on the right-hand side here. So what does that mean now? It means whoever has x here, we're going to equate it to whatever has x there, okay? So our equations will be a6 is equals to a plus b, and then whatever does not have x here, we're going to equate it to whatever does not have x there. So our second equation will be what? 3a minus 2b is equals to minus what? 2. So we have two equations down. We can solve them simultaneously. Then we find the values of a and b. Okay, so let's do that. So here we can, let's make a the subject of the formula. So 6 minus b is equals to what? To a. And then we get this 6 minus b, we replace where there's a here. So it will be 3 multiplied by 6 minus b minus 2b is equals to minus 2. So what do we get here? We get 18 minus 3b, okay, minus 2b is equals to minus 2. Okay, so that is what I'm getting there. Okay, so okay, that is what I'm getting there. All right, so now let's put the like terms together. So minus 3b minus 2b is going to give me minus 5b. And this is equals to minus 2. And then this 18 goes to the other side, so it becomes minus 18. So it means we have minus 5b is equals to minus 20. So meaning our b is what? We just divide by -5, divide by -5. So it means our b is what, guys? Our b is 4. Okay, so our b is 4. It can help us now to find our a. So remember our a was what? 6 minus b. So it means our a will just be equals to what? 6 minus b. But b is what? Is 4. So it means our a is what? 2. Okay, so we found our value of a, which is 2, and then our value of b, which is what? 4. Okay, so we found the values of a and b. Okay, so it means our partial fraction now we can write it as 6x minus 2 over 2x, okay, x plus 3 is the same as the value of a is 2, so we're going to put 2 over, okay. Someone has their mic and mute. I'm getting a feedback. Okay, let me just mute them. Okay, so where there was a here, we are putting 2 now, okay, and then we are saying x minus 2, and then plus where there's b, we are putting 4, and then we are saying x plus 3. Okay, so this here means that we've decomposed this partial fraction that we had into, this fraction that we had into what? Partial fraction. So that's how you go about it, guys. So any questions there before I go to the next question? Any questions there? Okay, no question. So let's look at another question there. Okay, let's look at another question there. Okay, so let's try to look at question number, okay, I think we can even do this same one here. Okay, let's do this second one here. Then we do the third one. Okay, so we have 7 minus 7. Okay, so we are on number 2. Okay, so we have minus 7x, then minus 12 divided by 2x, and then we have x minus 4. Okay, so I said the first thing is to check what? The highest power in the numerator and the highest power in the denominator. So the highest power in the denominator is 1 because this x just has 1. And then the highest power in the denominator, we are going to multiply this 2x multiplied by this x. So we have x squared, okay? So since the power, the highest power in the numerator is less than the highest power in the denominator, it means we can go on and find our partial fractions. So we are going to say this is equals to, okay, a over the first factor, which is 2x, then plus b over the second factor, which is x minus 4. Okay, so what is next to do here? It's just to multiply throughout by the denominator, okay? So we are multiplying throughout this whole expression here. We are multiplying it by what? The 2x multiplied by x minus 4. Okay, so if I multiply 2x, x minus 4 with this, it means the 2x, x minus 4 is going to cancel. So what am I going to remain with? I'm going to remain with minus 7x minus 12 is equals to, okay, and then this 2x multiplied by x minus 4 multiplied by a over 2x means this 2x is going to cancel with this 2x. So what are we going to remain with? A multiplied by x minus 4. So I'm going to write a and then x minus 4. Okay, and then this 2x here minus 4 multiplied by minus 4 multiplied by b over minus 4 means the x minus 4 is going to cancel, right? So we're going to remain with b multiplied by 2x here. So we're going to write plus b and then 2x in the brackets. Okay, and then from there, you just simplify your right-hand side. So this will be equals to ax minus 4 plus 2bx. Okay, so it means we have minus 7x minus 12 is equals to, so we have ax and 2bx. So we can factorize the x, right? So it means in the brackets we're going to have a plus 2b, okay? And then the x will be outside the brackets, and then we have a minus 4 outside there. Okay, so why is this not adding up? Okay, it's not adding up there. I don't know why. Because this here can never be equals to this. Okay, it can never be equals to that. So maybe we've made a mistake somewhere. Let's try to go through. Okay, so this multiplied by that, 2x. Okay, it cancels, we remain with this. And then this a multiplies by the x minus 4. We get x minus 4. And then on the other side, it means this is going to cancel out. We get the 2bx. Okay. All right, so I don't know here what we are going to do. Okay, so just a minute, I counter check. Let me just counter check. Okay. Okay, just a minute. I don't know where we have gone wrong. So here when multiplying, this a multiplied by this x is 4x. Then this a multiplied by this should be 4a here. So it's the one that I didn't see. Okay, so that's where the mistake was. Okay, so if I put the 4a there, it makes sense now. So it means this that has x will be equated to this, and then this minus 12 will be equated to what? Minus 4a. So our equations will be minus 12 is equals to minus 4a, and then minus 7 is equals to a plus what? 2b. Okay, and then from here, it means we know the value of a. We are just going to multiply, divide both sides by minus 4, even this side by minus 4. Okay, so it means our a will be equals to what, guys? To be equals to 3. Okay, and then here now we can find the value of b because we know the value of this a here. So it will be minus 7 is equals to a, which is 3, okay, plus 2b. So this will be what now? So it will be minus 7 minus 3 is equals to, and then you have 2b there. So this is the same as 2b is equals to, we have minus what? 10. So divide both sides by what? By 2. So it means b will just be equals to what? Minus 5. Okay, so we have our value of a and we have our value of b there. Let's write them here. A, we said it was 3. And then b is equal to minus 5. Okay, so we can write our partial equation. Okay, we can write our partial equation, which was this guy here. So minus 7x minus 12 divided by, we had 2x and then x minus 4. This is the same as we had a here, which is 3 now, over 2x. Okay, and then we had plus c, b over x minus 4. But this b is negative, so we're going to write minus 5 over x minus what? 4. Okay, so this is how you find the second one there. So any questions there, guys? Any questions there before we do the third one? Okay, all right, so let's look at the third one now. Okay, so the third one now, it has 3 factors there, but they are still linear factors anyway. Okay, so the first thing you check the highest powers. So the highest power in the numerator is what? Power 2. And then the highest power in the denominator will be x multiplied by x multiplied by x. So it will be power 3. Okay, So the power in the numerator is less than the power in the denominator. So we can decompose this one. So let's get it and decompose it. Okay. So we have 6x squared plus 5x minus 2, okay, divided by, and then we had x minus 1, okay, and then 2x plus 1. So we see that all these are linear factors, okay? So what does that mean? It means we're just going to write a over the first factor, which is x, plus b over the second factor, which is x minus 1, and then plus c over the third factor, which is 2x plus what? 1. Okay, and then from here, what are we going to do? We are going to multiply throughout by this denominator here. Okay, we are going to multiply all this by this denominator here. So we're going to write x outside here, x minus 1, and then 2x plus 1. Okay, so let's multiply. So this whole factor here, multiplied by this whole expression, we're going to get a 6 squared plus 5x minus 2 is equals to, okay? And then now let's multiply on the other side. So if I get this whole factor here, and I multiply it with a over x, it means this x and this x is going to cancel. So what am I going to remain with here? I'm going to remain with a multiplied by x minus 1, okay? And then x plus 2x plus 2. Yeah, plus 1, I mean 2x plus 1, okay? So this is the first one, and then we're going to say plus. So if I multiply this whole factor here with b over x minus 1, it means this x minus 1 and this x minus 1 is going to cancel. So what are we going to remain with? B multiplied by x multiplied by 2x plus c plus 1 there. So I can even write b multiplied by x and then 2x plus 1. Okay, and then plus, we are still going. Now let's multiply this whole factor multiplied by c over 2x plus 1. So what's going to happen? The same thing. The 2x plus 1, the 2x plus 1 is going to cancel. So what are we going to remain with? We're going to remain with c, which is being multiplied by x multiplied by x minus 1. So I'm going to write cx and then x minus 1. Okay, and then from here, what should we do? We have to expand this expression. So we have 6x squared plus 5x minus 2 is equals to, okay, let's expand whatever we have here. So we have a, and then let's expand this now. So x multiplied by 2x, we're going to have 2x squared. X multiplied by 1, we're going to have plus x. And then minus 1 multiplied by 2x, we're going to have minus 2x. Okay, and then what's it? Okay, so minus 1 multiplied by 1, we're going to have minus 1. Okay, and then plus, and then there we have b outside here, and then let's multiply this x with whatever we have here. So x multiplied by 2x, we're going to have 2x squared. Okay, x multiplied by 1, we're going to have plus x. And then here we have plus c, and then this x multiplied by what we have inside here, we're going to have x squared minus what? X. So this is what we have there. Okay, and then from there we see that what we have here can just be 2x, and then this x and this minus 2x will just be minus x and then minus 1. So let me write it like that. So this x minus 2x just becomes what? Minus x. Okay, and then we have okay, so this one becomes minus x, and then we have a minus 1 there. Okay, so from here now, what are we going to do? We are going to multiply with those a's and those what? B's and those c's. So this will be equals to a multiplied by this. It will be 2a x squared. Okay, a multiplied by this to be minus ax, then minus a plus 2bx squared plus bx. Okay, then let's multiply by c. We have c multiplied by that. We have cx squared minus cx. Okay, so this is what we have now. So we see that we have my x squared, my x eka, and those that do not have any variable. Okay, so if the meeting cancels out, okay, just join using the same. Okay, so what are we going to do here now? Okay, what are we going to do? We're going to group them. All those with x squared, we're going to put them together. All those with x's, we are going to put them together. And then all those without x, we are also going to put them what? Together. That's what we're going to do. Okay, so we see that 2x here as x